Welcome to The Explainer. Today, we're going to build a powerful toolkit. Why? Well, to master one of the trickiest challenges in all of computing, how to do a whole bunch of things at once without everything just, falling apart.
So let's kick things off with a question we can all get our heads around. I mean, think about it. You're in a crazy busy kitchen, or maybe you're just trying to get out the door in the morning, juggling a bunch of tasks at the same time. It's tough, right? Well, it turns out the exact same thing happens in programming. All right, so here's our game plan. We're going to start by unpacking the puzzle itself. Then we'll add 3 awesome tools to our kit: the notifier, the promise, and the assembly line. After that, we'll see how to unlock the Pro Toolkit, and finally, we'll look at what all this means for the future. Okay, first up, the parallel programming puzzle. Let's really dig into this challenge of coordination.
The really hard part of parallel programming isn't just kicking off a bunch of tasks. No, the real problem is figuring out when they're all done. It's like if our main program is the head chef, we can't have him running around the kitchen like a headless chicken, asking every single cook if their dish is ready. He'd get absolutely nothing else done.
All right, let's grab our first tool. This one is designed to solve that exact problem. No more constantly bugging our tasks to see if they're finished yet.
It's a pattern called join/await. And the analogy here is perfect. It's like giving each of your cooks a little bell. The moment their dish is ready, ding, they ring the bell. The head chef gets notified instantly and can deal with it without ever once having to shout across the kitchen, "Hey, are you done yet?"
And this really shows you the night and day difference. With a standard join, the program is either completely blocked, just sitting there waiting, or it's in this frantic loop, constantly checking. But with join await, the main thread is totally free to go do other important stuff until it gets that simple automatic tap on the shoulder. It is literally the difference between just being busy and actually being productive. So you might be asking, how does this actually work? Well, it's pretty clever. Under the hood, you're basically attaching a little to-do list to the task, what they call a termination handler. Think of it as the instructions for what the chef needs to do the second that bell rings. And it's all managed really cleanly through something called an iJoin interface. Okay, tool number 2. This one tackles a whole different but super common headache. What do you do when you need the answer from a task, but that task isn't even done yet? The answer is a really cool pattern called a future. Now, the best way to think about a future is like an IOU, or maybe a claim check ticket. When you ask your program to go calculate something, instead of waiting for the answer, you get this future back immediately. It's a placeholder, a promise that the result is coming. And here's the magic. Your main program can just take that future, that IOU, and go on about its business. No waiting around. It just holds on to that ticket, and then, later on, whenever it actually needs the result, it can cash it in. This completely separates the request for the work from the delivery of the result. And that right there is a huge, huge win for efficiency. All right, on to our third tool. So far, we've talked about tasks running in parallel. But what happens when the tasks aren't independent? What if one task's output is the next task's input? Well, for that, we need an assembly line. And that's exactly what this pattern is called, a pipeline. It's a fantastic way to create a super efficient assembly line for processing data. I mean, picture it. Each stage or each station on the line does one specific job and then immediately passes its work on to the next. And the best part? All the stations are working at the same time. The source material gives a perfect real-world example, a web spider. Just think about this assembly line. Station 1's only job is to download a web page. As soon as it's done, it hands the page to Station 2, which pulls out all the links. Station 2 then passes those links to Station 3, which adds them to a list of new pages to download. See that flow? Each stage is constantly working, creating this incredible, nonstop, super efficient process. Okay, so we've got our individual tools. We've got the notifier, the promise, the pipeline. Now, let's see what it looks like when we level up and get the whole professional toolkit. And that's where something like the OmniThread library, or OTL for short, comes in. You can think of it like buying a pro-grade, pre-packaged toolbox instead of building every single tool yourself. It takes all these powerful concepts we've been talking about and gives them to you as solid, ready-to-go components. It just makes your life so much easier. And OTL really does take our basic ideas to a whole new level. It gives you these incredible building blocks, like blocking collections, which are basically a super safe way for your different cooks to share data, or parallel task, which gives you really fine-tuned control over your background jobs. It's all about giving you a rock-solid foundation so you can focus on your problem, not on reinventing the wheel every single time. So,
We've built this amazing toolkit. What does it all mean? What's the big picture here for you as a developer, or really as any kind of problem solver? The real takeaway is that this stuff isn't just about raw speed. It's not just about making code run faster. It's about fundamentally changing how you think. These patterns give you the right mental models to take something that used to be this messy, complicated chore and turn it into a truly elegant and clear way of solving a problem. And that's what this explainer has been all about. Having the right tools doesn't just make old problems easier, it actually lets you start thinking about problems you couldn't even touch before. It opens up a whole new world of possibilities. So I guess the real question to leave you with is, now that you have a toolkit this powerful, what impossible thing are you going to go build?